Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Ives number 7255 pivot set. This is a complete pivot set that I have here. We're going to go through all of the components. First and foremost, this is a center hung pivot, and we'll discuss what that means in a moment. And as a result, it is a very common sort of pivot that's going to be used in a variety of installations. Everywhere from simply hanging a unusually a larger or heavier than typical residential door. I've sold this to people, contractors, woodworkers, homeowners, countless times when they're doing something a bit more exotic, like a concealed bookcase, which is actually a very common application for a center-hung pivot like this from Ives. This has a 500-pound capacity, which would be very appropriate for a bookcase sort of installation because, and quite frankly, I wouldn't consider anything less than a 500-pound rated pivot. The bookcase itself can be 100 pounds, and loading it up with books would certainly push you into that 500-pound range. Getting over that, Ives can help. They've got, Ives has pivots with greater capacity, but this 500-pound range is really a good pivot to use for doors that are half of that weight and up to doors in that range, so you handle a lot of door types. Minimum door thickness with this is 1 3/4. This will include the top pivot and the bottom pivot, of which we'll go into or through all that in a moment. The rest of the information below this video in the extended description is really things that we'll cover in a moment. There are links to two links to the top pivot installation instructions and to the bottom pivot installation instructions. Let's do a graphical tour of the items first, starting at the bottom of the door. Here's your floor plate. Large spindle bearing, that's here. Width of the floor plate, about 1 13/16 inches. Length, about 3 9/16 inches. Thickness of that material is 1/4 inch. To the end of the stud, about 1 3/16 inches. Here is the portion that fits into the bottom of the door. That's going to, forgive me. The portion that goes in the bottom of the door is here. Bearing packed raceway that's in there. Okay. Let's go over these dimensions. 4 15/16 overall width at the end of this. About 1.5 inches or so. About 1 5/16 inches here. Thickness, about 5/8. And then about 5/16 of an inch. So this is the portion that will be mortised into the bottom of the door. Moving up the door will be, of course, the head portion. This is the door portion that goes into the door and will obviously look like this. Very substantial piece of steel. By the way, this unit weighs just over 3 pounds. At least it does with its box. 1 1/4 by 9/16 by 4 5/8. Then, of course, your top pivot. And kind of a interesting design here. This is spring-loaded, the top pivot pin. And you access that by literally just pushing a screwdriver up into here. And then you can pop that pin in and out. And then, of course, you'll get a decorative cover plate for that portion, and it will look like this. That's the access hole for the screwdriver, your 2 finished screws to hold it on. There's your installation. Now, let's start with the bottom pivot installation instructions. Link below this video, they'll be obviously included. There is a definition of the parts. There is prepare the more, a verbal description of what you're going to go about doing. Prepare the door, mortise the bottom, locate, etc., etc. Screw packages are included, and with the bottom portion, you're going to get lead anchors, or expansion anchors, I should say. Lead expansion anchors. You will also get, the bottom line is this. What you're getting here is, this is your bottom package. Your bottom package is giving you the lead expansion shields, it is giving you machine screws for those, because that's what you would use for this lead expansion shield. It gives you like a number 12 by 1.25" screw for the bottom of this. So out of the package, they're assuming that this is going down to concrete and that you're using these lead expansion shields. They're assuming that a wood thread flathead, it's a sheet metal screw, but it's a flathead intended for a wood application, is appropriate for the bottom of the door. The logic on those lead expansion shields is quite simply this. The factory has designed it to handle 500 pounds. Having an anchoring system not up to the potential task is a problem, so therefore lead expansion shields. How you'll go about fixing the bottom portion to the floor will of course be determined in your process of installation, but that's why you're getting those anchors, because those anchors are tested to be compatible with a 500-pound sort of load and what can be expected. What I'm trying to say is you might need to go outside of the anchors that are here, but these are the ones that are compliant with this sort of installation. And that logic applies to heavier pivots where there are no anchors at all and that they're intended to be poured in concrete, because there are no screws that will handle, technically a tested operation when you're hanging a 1,000-pound door. 1,000-pound door? Sure. A lead-lined door in a hospital? Absolutely. Okay, so the verbal description gives everything that's important. The graphical stuff on the back is really quite frankly, the easier sort of installation. Here's what we have to know. Here's what we must do. From the jamb to the center line of the pivot, the vertical axis of pivot, the center line of this, center line of this, center line of this, and of course the portion in the top of the door, all needs to be plumb. No questions asked. That must be accomplished. There's no adjustment for it not being plumb. That dimension is a minimum of 1 3/4 from the cased opening frame. If it's a cased opening frame, it would be without an applied stop, and there may not be an applied stop anywhere. From the jamb, 1 3/4 minimum. That's a must. Minimum. It can be greater. It can be. I've had clients, quite frankly, that have called up and said, I have a 5-foot wide door. Is it okay to kick the pivot point in 18-inch? Sure it is. Absolutely. No problem at all. Door's only 250 pounds. Okay, no problem at all. I, quite frankly, would not want this pivot used for that installation. I would like a model with a longer bottom arm. But nonetheless, people have asked that question, and it's permissible to kick it out even further. That's number one. Number two, you see that they're showing a radius on the door edge. Radius of heel edge of door must not exceed pivot point to jamb distance. What that means is, let's say in this example, it's 1 3/4 from the jamb to the center line. The radius of the edge of the door that you have to come up with cannot be greater than that, because the aggressiveness of the radius would be insufficient to allow the door to rotate properly, to double act. Okay? If my palm is the flat jamb and my fist is a square-ended door, you need to round that over to allow for the very small margin that is there, which is not defined, but it would sure be 1/8 of an inch. Would in no way need to be greater than 1/8 of an inch. And I would plan on it being 1/8 of an inch, because that would be standard for the margin at the top of the door. Realistically, could probably a 1/16 might work as well, although, then you're really, that vertical axis of pivoting, if it's out at all, when you get down to that sort of margin, you'll see exactly where it's, where the door will make contact, unintended contact. So you must radius the edge of the door. You don't have to radius the edge of the door, but your gap between the jamb and the edge of the door will have to be significantly greater, let's say 1/4 inch. Well, that's inappropriate. That's too much margin, and that's probably not the design idea. If you're going for concealed hardware, center hung, which many people are when they're looking at this hardware, having a huge gap is not the idea. It needs to be clean, straight, tight, aesthetically pleasing. Nothing to detract the eye from the overall look. You might be, some gorgeous quartered ash veneer on a door. You certainly don't want to see excessive hardware and excessive gaps, whatever the scenario is. Now, how to go about radiusing the edge of the door, that's something that I happen to have experience in doing. And if you have any questions on how to go about doing it or anything, feel free to reach out to us. When I have done it, you'll take your door. Now, I would have a router set up with only a router bit for this specific purpose. I'd have a giant roundover bit with a bearing at the end of the bit, a 1.5 router, where I have taken the router base and I have cut it out to get this big router bit into it, and go about radiusing the edge of my doors. Now, on the hardware, it's very difficult to justify a $200 bit when you're going to do it once. You're going to want to certainly order this door from the factory radiused for you already, or you're going to come up with some other way to radius the door using a different bit or a bit that you might have, and it will look like a very different sort of door if you used a 3/4 inch roundover sort of bit. When I have done it, because it would be a production setting, the justification of the tool is there. So I would have my door laid down on a set of sawhorses, okay, and clamped down securely, because you've got 10 pounds of tool and you've got, let's say, 10,000 RPM of large bit spinning, or whatever the RPM would be, 6,000 RPM. I would start at one end of the door, and I would be sure that my router was absolutely flat on the face of the door, and my bearing would come up, and the depth of that would be set to get me halfway of where I wanted to be, because I'm going to flip that door over. And I would make one pass, and I'd be very careful not to push at the end of the door. And then I will always make one more pass, just one cleaning pass, which might take any sort of minor tipping that may have occurred and smooth that off. I'll take the door and I will flip it over, and I will do that procedure again, and I'll have a beautifully radius door. It's like the top row of tile in the bathroom. That's bull-nosed. Well, if you do a double bull-nose, it's a radius, and that's in effect what you're doing. So the problem with it, though, is in the door construction. Many architectural veneer doors will be 5-ply doors, will be 7-ply doors. You can have 9-ply doors. Think of it as plywood, except that indoors, the thickness of each of the layers is different. You'll have very thin layers and then a thicker layer, things of that nature. As you take and radius the door edge over, you accentuate those different layers. So if your quartered ash veneer is over a MDF crossbanding, as you radius that, you're going to see that dark line, or cherry, or maple. You're going to see disparate colors as you radius through those different layers of plywood. It's not plywood, but think of it as plywood. So take that into consideration. You don't want your doors to look terrible after you've radiused them over. Or have your factory manufacture the material where they have done no blackline material can be put down and over after it's radiused. I've had people manufacture doors where the style has been applied and there's a seam that's there, and the width of the style is substantial enough where there's no layers whatsoever because it's a block of wood. This is the realm of professional mill workers, woodworkers, people who are manufacturing products and encounter this sort of problem. I merely bring it up because doing it after the fact is something that you should consider prior to machining anything. So, radiusing the heel edge is step 2, and it would go to speak that the other side of the door you'd also radius. If you don't, you just have to have a larger margin. That margin is directly related to the door thickness. Minimum thickness for this door is 1 3/4 inches. You can have much thicker doors, but radiusing is typical. The third thing that you have to have is And forgive me for flaking out there, I needed to study that drawing. The third thing that you have to do is actually not expressly called out on the installation instructions. And that means the reference to this part, where it says 5/8 to 1 1/16 mortise depth. Bottom of the door to the mortise depth, bottom of the door to where this plane is going to be. The depth of the mortise, 5/8 to 1 1/16, is directly related to the undercut that you want to accomplish. Okay, so what is happening here is when you have the maximum mortise of 1 1/16, your margin at the end of the door, while it's not expressly called out, is about 5/16 of an inch, or thereabouts. So they show that with a funny notch right there, and I've never seen anybody mortise it that way. But I've just never mortised it that way in 2 steps, but there would be no reason not to, really, except if there was a reason not to. So here's the bottom line. We can determine what has to happen here. From the top of the arm to the bottom of the plate, you can see that that is 1 7/16, basically. 1 3/8. Let's say 1 3/8 less 1 1/16 is 5/16 of an inch. So if you mortised this to its maximum, you'd have a 5/16 of an inch gap. Now, plus or minus, very close. This is 1/4 inch, so you're really only going to have a 1/16 of an inch between the bottom of the door and this plate, and that's why they're showing it notched. As you decrease the mortise depth, as you make this shallower, the greater your undercut becomes. So 1 1/16, let's say, equals 5/16. 1 1/16 depth equals 5/16 undercut. As this becomes 1 inch, this becomes 3/8. As this becomes 7/8, this becomes a 1/2 inch. That table is not called out here from 1 1/16 down to the 5/8 undercut that they're referring to. It would be nice that it would be plainly stated. It's also nice that these installation instructions are really, there's not much to it. Although that data would be handy because you will have to, you'll say to yourself, okay, I've got a 3/4 inch undercut. What do I do now? You know, and it would be handy that that was at least detailed there. But having mortised pivots countless times, that's the third part of what you're going to encounter with that. Now, the logic on the top, if you have any questions on the bottom pivot, please feel free to reach out. The logic of the top pivot is all of the same logic. The verbal description of what has to happen, the mortising requirements of everything, that's here. The absolute mandatory vertical center line of axis, the vertical axis of pivoting needs to be plumb and consistent. Radiusing gives you the dimensions of everything, of how to mortise it. You know, obviously a router is the tool of choice for all of this stuff with a template. That's really just the way to go, and then squaring out the corners. I always, and without exception, will put a tape measure on all of the parts and compare it to the template. I'll do a reality check on the template. Not that they're ever wrong, but 2 yeses is better than, you know, 2 positives, confirmations is how I like to go about proceeding. Certainly, when you're mortising something for a client, you'll want it to be right the first time. You've got your depth. There's no decisions that have to be made on this. You just make it happen. You make it look like it's called out here. I'm partial to the Ives pivot line because, well, I'm partial to it because the installation instructions are easily accessible. I would like for there to be a little bit more information, especially about the undercut aspect. But when you get this piece of hardware and you look at the installation instructions, what strikes me first is, oh, this is no big deal. And it doesn't matter to all of you who have done it countless times, but it matters to the person who's doing it for the first time. I like Ives because it's good quality material, very reasonably priced, typically in stock, and approachable, meaning you get the idea relatively quick. And those are the reasons that I'm partial to the Ives pivot line. There is a link below this video to the manufacturer's page, and from there you can pull up the full line Ives catalog and review all of their items at length. If you have any questions on not only the Ives pivot line, but their other less common items like pin and barrel hinges, they have a comprehensive offering of all of the trim and auxiliary hardware that everyone knows the Ives name under. Door stops, push and pull hardware, kick plates, things of that nature. And the name Ives is synonymous with that material. If you have any questions on that or any other Ives product, please feel free to reach out to us. Thank you.